Hello everybody and welcome to the first unit of the ROS Manipulation course. In this first unit, which is basic concepts, we are going to have an overview, a first look to some of the concepts that you are going to learn, that you are going to work with during this course. Alright? So, first of all, what do you need in order to perform ROS manipulation? So what concepts do you need to know in order to be able to say that you know about ROS manipulation? Well, basically are these four main topics. The first one is MoveIt. You will need to know about motion planning as well. You will need to know how to work with perception, and finally you will need to know how to work with grasping in ROS. So, first of all, MoveIt. What is MoveIt? Basically, MoveIt is a set of packages and tools that allow you to perform manipulation in ROS. So MoveIt provides software and tools in order to do motion planning and other stuff like perception, kinematics, collision checking, even navigation. So MoveIt is a really huge and big tool, and it is basic, so you need to know how to work with MoveIt if you want to work with manipulation in ROS. Alright, so this first demonstration here will introduce you a little bit to MoveIt if you never worked with MoveIt before. So let's do this first demonstration, and the first thing we are going to do is to execute this command here. So let's execute it here in the web shell. This will launch MoveIt with a predefined configuration. Then you need to open here the graphical interface in order to be able to visualize MoveIt screen. There we are. Excellent. So yeah, this is the main screen in MoveIt. Yeah. So here I suggest you to have a look at the tool, at the different windows you have here, the different configurations. For instance, I'm going to do a very quick demonstration where I'm going to come here in the planning tab, and I'm going to select a goal state. In this case, I'm going to select this start position. Then I can click here in the update, and as you can see, my robot updates its position here in the MoveIt scene. Yes. Now, for instance, I can click here in the plan button, and the robot in MoveIt will start planning and showing this planned trajectory. There you are. As you can see, yeah, I can change, for instance, the position to a random position, which is valid, of course. Let's see, for instance, okay, let's try this one, for instance. As you can see here, it starts planning again, yeah, a trajectory, a motion, in order to reach this goal position here in MoveIt, yeah, and all of this is being managed by MoveIt. Yes, MoveIt is calculating this trajectory for me, so I don't have to worry about this, yeah, and this is a huge thing. All right. Okay, so let's stop this demonstration. Alright, so the next thing you need to know about is motion planning. You will need to know how to perform motion planning. And what is motion planning? Basically, motion planning is how to plan a movement from a point A to a point B without colliding with anything, yeah? So that's basically what MoveIt was doing in this demonstration for us, okay? We didn't have to worry about anything. But there are some things that we can do in motion planning. For instance, we can do motion planning with code, yes? So we can do motion planning with MoveIt, as you did there, and we can also do motion planning with code, yeah, programmatically. Okay, so let's try this demonstration again. This demo 1.2, where I'm going to launch again MoveIt. So I'm going to open again the graphical interface window. There we are. Although in this case I won't be using MoveIt, yeah, but I need to have the MoveIt environment started. So now what I'm going to do is to execute this code here. Yes, now I have a different configuration in MoveIt. So now what I will do by executing this code is to actually move the robot in the simulation, because as you saw previously, I was moving the robot here in MoveIt, yeah, but that was not executed in the simulation. So what I'm going to do here is to actually plan the movement but execute it as well in the simulation. I'm going to do it with code. Okay, so now if I execute this, let's put the simulation screen a little bit bigger. There we are. So now if I execute this piece of code here, let's see. We need to wait a few seconds because there are some slips here in the code, as you can see. And there we are. So the robot starts to move. Yeah, it has planned a trajectory, it plans some trajectories, and then it executes them. Okay, well, don't worry if you have doubts at this point, because this is just an introduction unit, yeah, in order to introduce you to some concepts, okay? But during the course you are going to learn all these topics with more detail, okay? As you can see, the robot keeps calculating trajectories and executing them. Excellent. So let's stop this demo as well. All right, so great. We have seen a little bit of motion planning in MoveIt and motion planning executed into simulation. Yes. So the next thing you will need to know about is perception. Okay, and perception is basically how you visualize the environment. Yes, or how so in order to be able to interact with any object in the environment, you need to be able to visualize it in some way. Yeah, usually this is done using, for instance, a Kinect camera like this one. Yes. One thing I want to mention is that in this course we are not going to do perception as a concept, because we have another course which is ROS Perception that talks about perception. Okay, we are going to have an overview at perception in MoveIt. Okay, but perception is a huge concept itself, so it has a course, a whole course for perception. Okay, you can have a look at it whenever you want. It is in the Robotic Night Academy. All right, but in this course we are going to see some things of perception related to MoveIt. All right. Okay, so let's do now this demo 1.3, which we are going to visualize a little bit the environment through the Kinect camera, through this Kinect camera which is placed here. Yes, so yeah, let's go. For that, let's first of all launch RVs in order to be able to visualize the point cloud of the camera. So we are going to launch RVs and again open the graphic interface. There we are, excellent. So here we have our robot, and now in order to be able to visualize the point cloud of the camera, we will have to add this point cloud to element. Yes? So let's add this point cloud to element, which is right here. And let's configure it for the topic which is publishing the camera data, which is, let's have a look. So the topic which is publishing the point cloud of the camera is this camera depth points. Yes, so this is the topic we should add here. There it is, camera depth points. Excellent. Anyways, now if we leave this like this, you will see that an error appears after some minutes because it's trying to load everything. You have to bear in mind that point cloud data is a lot of data, so it's a huge amount of data, and visualizing, working with this kind of data is sometimes heavy, so it makes everything go slower. Yeah, so you have to bear this in mind. Always you work with point clouds, okay? So let's advance while this is trying to load the point cloud. Well, we will get an error, I can tell you this. Yeah, so we will get an error here because we need to specify the frame where the camera works, and this we can get it by using this command here. So let's execute this command here, and here we can get the frame where the camera is operating, which is camera depth optical frame. Yes, so let's copy this frame here, which is the one we are going to use here in order to be able to visualize the camera. So here it is the error, yeah, as you can see, we have an error here, yeah, where it is saying that it doesn't find this frame, yeah. So let's, as you can see, nothing is visualized here. Yes, so now let's modify just a moment, yeah, in order to be able to visualize this. Let's put this camera, let's put this camera depth optical frame here as the fixed frame, and now, as you can see, here it is a little bit moved, but we are able to visualize. Let's move this a little bit. Okay, so here it is. I have moved the RVS screen so it can be seen better, yeah. So here we can see the point cloud of the camera. Yeah, this should be better configured, but for this course, since we are not really going to use this precision very much, it is not properly configured, okay? But anyways, this is the point cloud data of the camera, yes? So this is the data, let's say this is the data that will be used for perception in order to be able to know where the objects are in the scene. For instance, this ball, yeah, it can be using some perception packages, which you can learn how to use in the perception course. Using some ROS packages, you can know, for instance, the position of this ball in the scene, yes? Anyways, okay. Yeah, so we have visualized here the data of the camera, of the point cloud of the camera. So let's stop this demonstration. And of course, finally, you will need to know how to work with grasping. Yes, and what is grasping? Well, basically, grasping means to grasping means grasping is referred to the action of catching, of getting an object from the scene, from the environment, for instance, this ball here, yes, and doing something with it, doing an action with it. For instance, moving it to another place, yeah? So for instance, catching, grasping this ball, which is placed here in the table, and moving it to this other side of the table, yeah? So this would be grasping, okay? Catching, getting, interacting with an object in the environment in order to do something with it. Yes? Excellent. So, yeah, in the introduction of the course, in the previous unit, you already saw a grasping demo, so I'm not going to repeat that here. Okay? Excellent. So, summarizing, what do you need in order to perform ROS manipulation? You need to know about MoveIt. You need to know how to perform motion planning. You need to know a little bit of perception as well. And you need to know how to perform grasping. Yes? So these are the main topics which are directly related to ROS manipulation. But, of course, you need a manipulator robot. Yes, without a manipulator robot, you cannot perform ROS manipulation. That's pretty obvious. And what is a manipulator robot? Well, a manipulation robot basically is any kind of robot that is able to physically alter the environment in some way. Yes? So, what means alter the environment? So, for instance, catching something that is in the environment and placing it in another way, in another place. Yes? So for instance, picking this ball and placing it here besides in the other side of the table. Yeah? This way you are altering the environment because you are modifying how the environment actually is. Yes? So a manipulator robot is any kind of robot which is able to physically modify the environment it works in. Okay, and any manipulator robot is composed by these three elements, by these three parts: links, joints, and an end effector. Yes, so what are the joints? The joints are basically the articulations of the robot. Yes, so the joints will be, for instance, doing a parallelism in humans, the joints would be, for instance, the shoulder, the elbow. Yes? That would be the joints. Are the parts of the robot which can move, which can actually move, rotate, which make the robot move. Okay? Then the links are the parts that connect these joints. Yes? So, for instance, the joints in this robot we are seeing here will be this one here, this one here, yes? These would be the joints because are the parts of the robot which actually perform a movement, a rotation, yes? Then the links would be these parts, like this one here, that connect these joints. Yes, these would be the links. And finally, the end effector is the gripper, the tool, whatever you place at the end of the manipulator robot. Yes, in this case it is this hand here, this gripper here. Yes, this would be the end effector. So it's the gripper or the sensor which is connected to at the end of the manipulation or at the robotic arm. Okay, for instance, you can see here a diagram showing this. Yeah, so this would be the joints, the links, and the end effector. Okay, this is talking about this robot. Excellent. So now more or less we know everything we need in order to perform ROS manipulation, yes? Then there is as well some basic terminology which will be good to know. For instance, the degrees of freedom of a robot. Yes, basically the degrees of freedom are the different ways in which a robot can move. Okay, so for instance, let's talk again about humans. Yeah, let's explain it in humans because I think it's easier to understand. So for instance, our shoulder can move up and down, right? But you can move also your shoulder to the side. You can move it left and you can move it right. Right? Yeah, so you can move it up and down, but you can also move it left and right. So our shoulder, we will say that it has 2 degrees of freedom. In the other hand, for instance, the elbow, you can just move it up or down, right? You cannot move your elbow to the left or to the right, yes? So you can just move it up or down. Then we would say that the elbow has 1 degree of freedom. Okay? Then each joint, of course, has its degrees of freedom, and depending on the robot, depending on the joint it has, on the movement the joints of the robot have, the robot would have a specific number of degrees of freedom. Yes? Usually for manipulator robots it's between 5 and 7. Yes? So that is the degrees of freedom, and it's something which is important to know in ROS manipulation. Yeah, here you have a very small, quick and easy exercise, which is to determine the number of degrees of freedom that the simulated robot has, that this robot has, yes. And finally, another basic terminology you need to know is the gripper. Yeah, so a gripper basically is any device that enables the holding of an object to be manipulated. Yes? So for instance, you have here a picture of a gripper, and this would be as well a gripper. Yes? Because it enables the robot to hold an object. For instance, this ball here. Yes? With this end effector, I can hold this ball and do whatever I want with it. Yes, so this would be a gripper. Okay, and yeah, that's all for this first unit. We have done a quick overview of all the contents you are going to do during this course. And yeah, let's see you in the next unit where we will start working with MoveIt. So goodbye.